Hi friends, welcome to our channel. So in this video, we want to analyze problem 1014, best sightseeing pair. In this video, we're going to analyze the main assumption of this problem. Then we do a simulation and then we write a simplified version of the solution. So here, basically, we are given an array called values, right? So we want to find a pair. So let's say ig, such that this expression is maximized. So that's the main assumption. So we want to return this score. So in example 1, so if you look at I equals 0 and j equals 2, and then you compute this sum, that is 13, then plus the difference of the index, that is 2 minus 0, that is 2. So overall minus, right? So you are going to get the 11, right? So the sum of the two values, because I is less than j, this essentially is a minus the distance, right? So in example 2, the length is 2, so it's very special. We can only use I equals 0 and j equals 1, then we get 2. So here is the length, right? So basically determines the problem size and also tells us we need to pay attention to the algorithm time complexity. So here the values are positive, it's strictly greater than 0, right? So with that said, I guess we are ready to do the analysis. So here I think the main assumption is this v. I'm going to use this v to represent the value vi plus I. Then so vi plus vj and plus I minus j. So here we know I is a smaller one, so I is less than j. So this is the expression. So if we want to maximize this, actually we can see this is essentially decoupled in the process of coding, because we can write this as vi plus I, then plus vg minus g. When we look at g index, right, then we should have already seen the previous ones. So then we can ask this question. So when we look at index, say g, so what are the previously maximal, say vi plus I, right? So then if we can find this value, then what we do is to just this is the max previous this expression, right? So then we just need to add the current vg minus g, right? So because this one vg minus g is decoupled from vi plus I, so that's actually what we do. So then when we look at each index g, so we want to find the previous largest vi plus I, then we just form this score, and then we compare the maximum over all the j's, then we will get the result. So that's basically the main idea. So basically we need to think or ask the right question. So once we have this, then essentially if you have practiced quite a lot for leetcode, you should be able to come up with a linear solution. But here, for the purpose of demonstrating the main idea, I first do a solution using heap. That is, I want to simulate. So basically, heap simulation. Basically, for each index, so we want to find the previous largest vi, in other words, the value minus plus index, right? Then we form the score. So for sure we need to return the maximum one. So that's our main idea. Let's first initialize a heap, right? Initially it's empty. Then when we scan these values, we always get push things into the heap because we want to find the maximum one. So here in Python there's a min heap, so we can store this number vi plus I, right? So then the minimal one, then you put a negative sign, it corresponds to the largest one. So that's the same. And then the result, I can initialize it as 0 because all the elements, so this value is always let's see, for values I plus values j, I minus j. So if you are not very sure, so you can put, say, float infinity, or a large negative number, right? So for example, you can, anyway, let's put it like this. Then what we want to do, so we are going to iterate. So for I, v in enumerate, so values. Then we want to check. So because currently we are looking at a larger index I. So if heap, if the previous heap is not empty, then we can find the previous largest value corresponding to this one. So that will be previous max. So I'll just use previous. It will be heap q, heap pop from this heap. And then I want to put a negative sign. So this way we get the positive one. And then what we want to do is we want to find, so the current score will, this is the previous state of the result. Then the current score will be the previous plus the current value minus its index, corresponding to vj minus g, right? So once we have this, because we are going to continue, we need to push back this one. So basically heap q, heap push. We want to push back this negative previous. Let's see. Yes. So always, if we look at the next one, so for the current one, we need to do this heap push, heap, and then v plus I, right? So, but we want to push the negative, so we actually put a negative sign in front. So this is what we want to push. So this way, at each index I, so we can locate the previous largest expression for this one, and then we form the score, then we take maximum. Then after we do the for loop, and then we are going to get the result. So we just return result. So this is actually a very brute-force solution in a sense. This for loop overall is O of n. N is the length of values, but here we have heap pop and heap push operations. Some can be logarithm time complexity operations. But let's first do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So I guess here I want to mention. So this is important, right? Because if we do not push back, then if we look at the next index, so this heap will not store all the previous negative such expressions. So we may not have the global minimum in front of this index I, right? So this is the one solution. So if you analyze this solution, actually there are two pieces of information that are very important, or you can examine from this question we asked. So when we look at an index G, right, let's see its current index. So we just need to know the previous maximum vi plus I. So for this expression, we just need to use a variable, right? Then running variable. And each time when we iterate, we just update this expression. That will be fun. So in other words, we can have an linear solution. Let me copy this part. And we can write a more time efficient solution. Let's do this. Max previous. So I can use say result to be a very small number, let's say, because we are going to take maximum. But here I guess there's some consistency issue. But here I'm using a float number, but you can use a very negative integer because the return is integer. But you know, if you do this, and then because all those things this expressions gives you integer, right? So in Python, this is not very rigorously required. So this is the one, and also I want to initialize a result. So let's just use this one, the result, and press the maximum. Then we are going to iterate, right? So for I in range 1, 2 length values. So notice that we didn't iterate from 0 because we need to consider the previous one, right? So max previous before this I. So we need to have the max of the max previous. Actually, I can also use a very very small number, but because this max previous, we are going to store this expression vi plus I. So v is strictly positive and I is also non-negative, so this will be strictly positive, so we can use this 0. So this way we will get maximum previous, that will be values I minus 1 plus I minus 1, right? So the value plus the index. So this is the maximum previous. Then we can update the result. The result will be the max of the previous state, and then if we use the current index as the larger index, what's the score? The score will be max previous plus values I minus I, right? Then after this for loop, we can just return the result. So this is another solution. So here, let me check. So here, because this value is greater than 0 and this value is greater than 0, the distance of this I minus j is at most the length of this one. So here, in order to to avoid this float and the integer inconsistency, because the length is at most this number, so I can actually use a very negative number, right? So it's 5 times 10 to the power 4, and then let's see, minus 1, right? So let's do a test. Yeah, it passes the first example. Oh no, I didn't change this to be version v1. Let's check. Yeah, let's look at general case. Yeah, it passes all the cases. So here, actually, I want to make a correction again. So though it was not very strict, so here I can initialize this to be 10 to the power 4. So this is so let's see, minus 1, as you like. So let's change this v2, and this is v. Let's do a test, right? Yeah. Anyway, so this is actually very close. It does not matter. So I guess that's basically about it for the current daily challenge problem. So here, let's do a quick summary. So in the first solution, which is very brute force, so we use a heap to simulate the process. So in other words, for each index we are looking at, then we want to know the previous largest vi plus I. And as long as we know this, we can form the score. And in the process of scanning the list, so we can update the result using this maximum. So this is the first version. And based on the first version, or based on the intuition we established, so we can write a much shorter and more time efficient solution. Because at each index, we just need to know the previous maximum expression for this one, right? Vi, the value plus index, and then we form the score and take a maximum again, right? So this way we get a linear solution. So with that said, I guess that's basically about it. So here also I forgot to mention that the case thing actually as a mathematical expression. This expression, this score involves both I and j. They are not decoupled. However, if you think of the for loop, right, and you look at the current I and j, so you can group vi plus I and vj minus j separately. In this sense, so the two parts actually are decoupled. This is the key for the solution. So with that said, I guess that's all about this video. Thank you for watching.